Hi everyone, thanks for coming for the first NestJS meetup. Really appreciated. Thanks, Michael, for the introduction, for opening yourself as usual. I appreciate that as well. Thanks Encoders for organizing this and hosting us. So, as Mika said today, we will talk about authentication and authorization strategies with NestJS and OI. So the goal of this session is to introduce you to OI, because I can imagine it's an underrated toolkit for identity and access control management. So out of curiosity, how many of you know about OI? Yeah, I gather. Yeah, so did you try it or just heard about it? Okay. I will try to heal that and give you the will to experiment with it. I hope I will reach that point. A few words about me. So I'm Edouard Maleix. I'm French, as you might guess from my accent. I'm a freelance consultant focused on server-side JavaScript. For the past 5 years, I've been working on dozens, maybe even more application and libraries with NestJS on NX, in an NX mono repository. So I use that experience and share it in articles that I write, in this talk as well. And you can check those articles, by the way, on Pushbase or Dev2, because in fact this talk is coming from an article. So if you want to know more about it, you can have a look at this article, and it will go a bit more in depth than this short talk. The agenda for today, I will start with some few industry insights, just to review quickly the landscape in the application, web application security. We'll see then in about OI and how it fits in that context. I will also introduce you quickly about it. I will discuss then what we'll build, so what application we'll build to put OI into practice in NestJS. We will then dig into how to set up OI locally so that it can work on our machine. Once the OI setup is done, we will move on to NestJS integration. So we will see how to integrate OI API into our backend application. And then we will make it run and see how it works. If we have enough time, we might do a live coding. Otherwise, I prepared some recordings, so I might just comment the video. Let's see how it goes. Hopefully, after this session, you should be ready to try OI at home. If not, you can still read the article or get in touch with me. So first of all, do you know the difference between authentication and authorization? Yeah, we all got it clear? We're sure about that, because sometimes there are ambiguities. And even just yesterday, I was reviewing a PR, and it was still not clear for a peer who starts and what's the purpose of each one. So just to clarify, authentication is the act of verifying credential, or verifying the identity of a user or a machine. So to do so, it will check the credential. If the credentials are valid, it will either deny or grant the access to user. Then follow the authorization. The authorization process is the process of checking the permission of a given authenticated user or machine. So we simply try to answer the machine, simply try to answer the question, has the user permission? If yes, then we grant the access, otherwise we deny. Hopefully it makes things clear. Now let's move on with those insights I mentioned. So according to OWASP Top 10, so maybe a few words about OWASP, because maybe everyone is not aware about OWASP. It's a foundation that promotes web application security. They write documents, exercises, challenges, toolkits, lots of tools to make you aware and to improve the web application security. And in one of those references is the top 10. So it's a list of the most common web applications vulnerabilities. So if you don't know about it, I think you really should have a look, like right now. Put yourself a reminder and have a look right now, because it might bring awareness to things that you overlooked that happen to the best of us. And in that list, the most common security vulnerability is broken access control. And the broken access control, an example is, for example, when a user can act as an admin, or when a given user can access another user resources to view or edit at worst. It can also be manipulating objects. So for example, you just pass another user ID in the payload, and then being that's it, you can access to the other user account. That might seem trivial, but I think if we all look in front of our own doorstep, we might be a bit concerned, if we are honest. Now, how come this could happen? Why this kind of trivial issues can happen? One of my theory, and also Jonathan Whittaker theory, who's a staff software engineer at Auth0, is that authorization has been for too long an afterthought. So I guess you also went through that. You start a new project, you think of all the great features, of all the things that can bring business values, but then there is no clear plan on how authorization is going to be managed. There is not yet much common standards or common products ready to ship that are available out there. For authentication is done. It's something which is pretty common to not roll your own authentication. It's even a common saying. But for authorization, it's still something that needs a bit of time, and that's where ORI might be useful. I will let you know a bit more. So, what could be the solution to this problem? One, I think, is that we, as backend developer or people who work on full stack, we need some solutions which are simple enough to maintain and manage in-house, efficient because we don't want to trade performance with security, obviously, cost-effective because the budget is rarely increased about security, except if we already are victim of a data breach, and ideally based on open standards, because we don't want to be locked in a vendor solution. We want to be able to have a solution which is which can support changes and for which we can switch without much cost. Let's see now how ORI fits in that context. So, what is ORI? That's the first question. Quick timeline so that you have an idea of the story of ORI. It started in 2014 as a pure open source project with the intent to provide a complete suite of web application security tools. So it covers authentication, authorization, and even OAuth 2 connectors. So in 2019, the founder of the open source project created a company, so in Germany, and built the ORI network product. It's built on top of the ORI open source stack, but it's hosted on the cloud and provide many benefits, including this one in 2023, that the platform is ISO 27000 and SOC 2 certified. So what does it mean? Is that you can use this solution for enterprise product. And that's what led me to delay so much experimenting with ORI, because I had to work with Auth0 in the past just because of that reason, because of those certifications. And I might not be the only one in that situation. And this year, it feels like the company is really about to scaling up with a new fundraising and the appointment of a new CEO who is really deeply rooted into the IAM landscape. So I would suggest to place your bet on ORI. At least that's what I'm doing. So as said, ORI, it's a complete tool suite of web application security tools. And it contains several independent modules. The one that we'll focus on are ORI Kratos and ORI Keto. Starting with ORI Kratos, the authentication counterpart of ORI, which has the following feature. So, first of all, it has a self-service API. Self-service API is what you will use in the front end. So that's what you can use to register your user, log in your user, verify your account email, recover your account access in case you lose it, modify your profile settings, and so on and so forth. What makes it customizable are those identity schema, which allow you to define the properties of your user, the authentication flow that they will support. And you can have multiple schema so that you can have different type of user affected to a given type of schema. Oh, sorry. It supports multi-factor authentication. That should be pretty obvious. So it has all the modern solutions, so TOTP, WebAuthn, even passkeys very recently. It also had admin APIs that you can manage identities on your backend and also do some batch import and do some migration from your existing authentication solution. And a great feature are webhooks, so that you can bind some custom logic into ORI authentication flow. So let's say that you want to trigger a custom email after registration. You could trigger a webhook after registration. If you have a beta phase and you want to close sign up for a given period, you could also have a webhook triggered before and just stop the sign up and say that, okay, we are closed at the moment. That's just example of one of the many things that you can do. Let's see an example of what a flow looks like in OI Kratos. So let me take my pen. Here on the left, we have Alice, our user. On the right, we have Kratos. So Alice will send a request to Kratos saying, okay, I want to register. Kratos will send back a form, at least some data that can be rendered into a form, and will create a flow that allows to track registration. Then Alice sends her credential, fill out the form, and Kratos send back, or create an identity and send back the identity. So in between, we could also imagine an extra step where Kratos would send a request to our backend over here, and then the backend would reply, intercept the request, and eventually modify the identity or do its thing, and then send back the identity to Alice. So that's an example flow, and all the other flow are a bit similar with this back and forth between user and OI Kratos. Another flow, which is a very important one, obviously, is between Alice, our user on the front end, our backend, and OI Kratos. So Alice would send a request along with the cookie that she received after login. The backend would send the cookie to OI Kratos to retrieve a session. Kratos would, in case of success, reply with the session that contains the identity. So identity being an acronym for a synonym for user or account, if you prefer. Then the backend can process the request, whatever it was requested by the user, and send back the response to the user. In another case, let's say that this cookie is invalid, the session is invalid, or whatever other reason. So we will just receive unauthorized access that we can, as the backend, forward to the user. So that's it for Kratos. Let's quickly discover OI Keto, the authorization part of OI. So OI Keto is based on a very interesting concept. They use what we could call declarative models. So instead of having some explicit statement or some explicit code that will define our authorization rule, like some backend code that will check, okay, this is the user logged in, let me check the owner ID, which is the foreign key of that given table, and check if the user has access. Instead of doing this, you have some separate models which are really responsible to receive all your rules. How you format those rules? You will use the ORI permission language to do it. So the ORI permission language is a subset of TypeScript. So it's not Turing complete. It's really a very simple part of TypeScript where you can define your namespace, your relation, and your permission. And I will show you in an example soon what it looks like. OI Keto also has the relations API that allows to create, delete, and update the relationships, and the permission API that you will use for your authorization check, so to check if a given user has access to your API. So let's do a bit of Keto grammar so that it becomes a bit more concrete for you. That declarative models I mentioned, because I know it's so abstract. Let me take my pen. So at the top here, let's imagine that these are two rules set. So we say that document owners are a set of user. So document, imagine that as an entity in our database. Same for the user. And that's the thing that we bring, is that document owners are a set of user. Based on that statement, we can say also that document owners can edit. So these are our two rules. Some instance of those rules below is that, okay, I will create the relation user Douglas owns the document JavaScript, the good part. Okay, so let's say user Douglas create the document, so we create that relationship. And later on, if we would need to check the permission, we would more or less ask to Keto, can Douglas edit the document JavaScript, the good part? And that's almost as explicit as that. But let's go on and go a bit more concrete. So, an example flow. Let me take back my pen. Once again, Alice, our backend, and now this time this is Keto over here. So the backend will send a request once again for the authentication. We know that part already. In case of success, we receive our identity. And what's new here is that you create a relationship after you receive the document. So you create that link between the document and Alice. Keto send back a successful response. We are on the happy path right now. And then we can send back the successful response. So at that stage, okay, we have our relationship. Now what can we do with that relationship? There's a second scenario where we want to edit the document. So we have Alice, once again, that authenticates and send a request to edit the document. So our backend will ask to Keto, can Alice edit that document? Okay, case one, yes, Alice can edit the document. We handle the request, modify the document, store it, and whatever, and send the response to Alice. Other case, okay, no, Alice has no link with that document, so the backend should forward the exception. All right, so that's it for the theory about ORI. Thanks for holding until there. We'll soon be more concrete. Let's see now how we'll integrate ORI. What will be our application? So we'll build a cat fostering application, which is a hub that will link cat guardians and potential foster who love cats and who wants to host them in their home. Key features of that app will be user authentication, profile management, user roles and permission, cat profile listing and management, and fostering matchmaking requests. So plenty of holes potentially for authorization. The architecture will be very simple. The self-service UI is a component pre-built by ORI, so that's pretty handy for backend developer like me who are pretty bad front-end developer. So you will have in it everything to log in, to register, to recover the account, and so on and so forth. ORI Kratos, that you now know, will receive the request from the self-service UI for the authentication purposes. It will send the webhooks to our NestJS application, which in turn will also send requests to ORI Kratos for the user verification. And the NestJS app will send requests to Keto to create relationships and check permission. And here, the basic will have a Postgres database to store our entities. So our entities will have some user, some cat profiles, some fosterings, request. Pretty simple. Moving on to the setup with Docker. So we will use Docker for our local environments, because I think it's the most straightforward way to do it, because Docker provides very up-to-date and very lightweight images. You could also use it in production at your own risk. But this setup could be ported indeed remotely if you are able to handle the security and the access, or if you use a private network. So starting with our Docker Compose setup. So here we'll have those 4 images: Kratos, the self-service UI that we mentioned, Keto, and Mailslurper, which is a simple server UI that will receive our email and allow us to mock an SMTP server. Makes things a bit easier for local development. We expose the ports that we need to access in our NestJS backend. We override default command with our own configuration file. And we create a binding with some local volumes to give access to all the configuration file for Kratos and Keto. So now, speaking of the configuration file of OI, we have many flavors to configure those files by default. But here I picked a more custom path inspired from Auth0. So I don't know if anyone has experience with Auth0, but they provide an interesting way to reuse your configuration file, which is templating, simply. So you can use some YAML weird notation here. Let me take a pen with the right color for the contrast. Here you see those template placeholder starting with 2 hashes. This is for primitive, so to replace string, boolean, numbers, you would use this notation. And for array replacement, you would use the double@ notation. So your configuration file in the end would look like this with those weird placeholder. And by passing your environment variables, you will have some magic happening and some environment variable substitution that will replace those with real values. And that's what you can then pass to your Docker containers. All right, now that's an heavy one. That's the Kratos configuration, and there are lots of things to configure. One of the great things of Kratos is that it's really very highly customizable. You have really so many options that it's one of the difficult things when you start with it. You can be a bit overwhelmed. So we'll just highlight quickly some of the important options to get started with. So the cookies, obviously, that's what you can get wrong from the get-go. So Kratos use cookie and session-based authentication. And they are pretty strict with security by default, so they really force you to have cookie only available across a single domain. And so you better get that setting right. So the idea is that if you work locally, well, you should just stick with either the loopback IP, so 127 blah, 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 or 0.0.0, or localhost eventually. But you have then to stick with it from your front end to your self-service UI, and obviously Kratos, so that it creates the cookie with the correct domain. The courier, so that's simply to configure your SMTP or HTTP mail sender. The DSN stands for data source name, so that's where that's the URL more or less of the data source. By default, it will store only in memory your data, which can be handy for testing. Identity allow you to list the location of all your schema that we mentioned previously. We will zoom in the schema in a minute. Self-service is probably the biggest part of the Kratos configuration. That's where we can specify and configure all the flow. So all the URL, all the webhooks will be defined in that place. An example here for the login flow. Here we configure the after effect. So here, if a user logs in with a password, we would trigger this webhook with that given variable method. The authentication would be set this way, so that would be an API key method. So it means that we would have a header with this given name and with this given value set. So that allows us on the backend to intercept and authenticate the request. And then here, everything is the detail of how the payload will be formatted, how it is expected to be handled by your backend. These are the methods that you can configure that are supported by OA Kratos. There is now also the passkeys. So passkeys were made available after I created this presentation. So I'm a bit outdated here. Serve is simply, well, as you can guess, how to configure the Go server that is behind the scene. And now the identity schema. As you can see, it's really a very simple JSON schema. Here you define the properties that your user is expected to hold. Here we have it very simple, just an email, which is expected to be the identifier for our password credentialed. And we expect to do some verification by email and recovery by email as well. Here, an interesting one. So when you send webhooks, Kratos will use a specific file to format the payload. Does anyone recognize this format? Do you know this syntax? That's a quiz where I always win, usually. But I would like to be surprised. Someone said Python? No? No one dares? No? Okay, I stop torturing you. This is JSON.NET. So yeah, that's very strange. It mixes data structure and a bit of logic, as you can see here. So I think it's a thing created by Grafana, but you should look, ask Google or whatever to get the truth of it. So here what it does, it will evaluate the identity passed in the webhook. And if in that identity we have the email starting with test dash, then we just stop the webhook, we cancel it, which can be pretty handy for testing. Other case, so in fact most cases, we will just format our request body with this JSON value. So we will have just a property called identity with the content of the identity. So that's what our backend should expect to receive then. Now, Keto. So I said I would be a bit more concrete with Keto. Now is the moment. So this is the subset of TypeScript I mentioned. So I guess if you look at it, you really can think it is TypeScript. You should be familiar. So everyone familiar with TypeScript should be, I hope, familiar. So the content of those namespace files are a bit comparable to domain-driven design aggregates, where you have all your entities and relationship and basic business logic into it. Except that here is just authorization logic. So for each namespace, you declare the expected relation. So group, imagine that the group could be an admin group. In that group, what we would have some members. So it means that there will be a relationship between user namespace and the group namespace. A bit more interesting and complex, the cat profile. The relationship of a cat profile could be owners, which would be user, or editors, because in our cat fostering app, we want admin to be able to edit our cat profile as well, to edit or delete for moderation purposes, let's say. And with this notation, using the subject set, we will allow some group, to edit our cat profile. For the fostering request, we will have a relationship with the cat profile, obviously, and the foster user, so the participant, those who requested to foster a given cat. And now the permission. So the permission will make use of the relationship to compute if whether or not the user can perform this given action. So as said, for the cat profile, you would be able to edit a cat profile if you are part of the owners or if you are part of the editors. You could foster or request to foster a cat profile if you are not an owner, because obviously you don't want owners to request to foster their own cats. That would not make sense. For the fostering, we want to permit the approval action if you are a cat profile owner. So it would traverse the relationship with the cat profile and access the owner via the cat profile this way. The rejection, we just reuse the same condition as for the approval because it's the same principle, same business logic. For the addition, we just want the participant of the fostering request to edit the request. And for the read access, we want those who have approval right and those who have edit right to read the request. Hopefully, everything is becoming a bit more concrete with OI. And more importantly with OI Keto, because I know these parts can be very, very abstract, but we're getting there, Let's now move on to the integration. So that's where we get concrete, that's where we really see OI in action. So, sorry? Sorry for the interruption. Little technical issue.
But go on.
Okay, I'm going on and hopefully the screen will keep on going as well. So we'll start by configuring our NestJS application. I like to use some classes to do some validation of the environment variables. So here that's just an extract. We will have our endpoint to the OI, Keto, and Kratos API. We will have the OI action API key, so that's what Kratos will send to our backend, and that we'll use to authenticate the request. And here, these are API key that we would fill out if we would use OI network, so if we would use the cloud-hosted solution. In the backend, we will handle two types of webhooks. One after registration, one after login. So let's study the case of after registration. So what we want to do is once a user registers on Kratos via the self-service UI, we also want to create our own user on our database so that we can still create some links between that user in our database and our own set of data using some foreign keys. So we don't depend on the identity created on OI Kratos side. So let's say that we have that user/on-sign-up endpoint. That's where we will receive the webhook request. First of all, we will pass through that OI action guard that will take care of validating the header that we mentioned previously. We will have a validation pipe that will ensure that the request is formatted correctly so that it contains the identity that we expect. If it does not, we really take care of formatting the error as OI expects so that we can display that error in the front end as well. And very importantly, we set the correct HTTP status code. If we want to be able to mutate the identity sent by OI to create a binding between our user and OI identity, we need OI to accept that mutation. So we need to set the HTTP status to 200. The OI action guard is very simple. It implements the canActivate interface from NestJS. In the canActivate function, we will do a comparison between that header that we mentioned that we receive and the API key that comes from the environment variables. Here, very, very simple, very straightforward. The ORI webhook error is following the schema documented by ORI. So an instance pointer, which is optional, and that will allow us to say, I want my error to appear under that given field on the UI, and the messages, so the message that I want to display on my form. This is just an extension of the default HTTP exception from NestJS. The idea is just to avoid having a specific exception filter in NestJS to handle the error correctly. Otherwise, you will need an exception filter that will format the error in your correct JSON format. Here, this way, it's a simple trick to ensure that the format of the error is how ORI expects it to be, with a status code property and a messages array. In the end, if everything goes well, that's how the error should look like. me switch color of my pen. Let's say that you have an invalid email address. It should be rendered correctly under the given field. And same for the login. Now, as for the implementation of the logic of the user creation, that's also pretty straightforward. We check, first of all, if there is any user. Sorry, wrong color. If there is already an existing user, we don't have any reason to go on with the flow, so we interrupt the flow. We send an error formatted as expected in the ORI format so that we can display the error correctly once again. And then we save our user in our database, and very important step, we create our binding. Here, by assigning and under identity metadata public the ID to our internal user ID and sending it back to the response, we create the link, we create the binding. And it means that when we want to verify our user, we'll be able to reuse those two identifiers, the one from the ORI Kratos identity and the one from our database. So that's what I will show you right now. Let's say that we have these users get current user endpoint, where we just return the currently authenticated user. So we will have an ORI authentication guard. So this is a guard that I created in an open source library, which wrap the API from ORI. So that makes it very straightforward to integrate it into NestJS. We have a cookie resolver and a session token resolver, so that you can say, okay, pick the authentication value from that part of the request. Next step, this guard will send a request to the self-service API to say, okay, does this cookie relate to any existing identity? If yes, we go to the post validation hook. And in case it's positive, we assign the user to our request context. And here we can see that we can retrieve our ID that we bound to the identity. And we also have the identity ID. So this way we are on the safe side. We know who's authenticated into our app, and we can track the status and the user across the rest of the flow, including the authorization. So first of all, how to create relationships. So let's say that this user, this newly created and signed in user, want to create a cat profile. It will call that a given cat profile endpoint with a post request. We will of course check that the current user is authenticated correctly with this guard. And the implementation is the following. So I just wanted to appear good, so I wrapped everything in a transaction. I hesitated to make a shortcut, but you definitely have to wrap that logic into a transaction, because if things go wrong at any step, you need to be able to roll back and ensure that all the relationships that you create are deleted. So here we create our link between our newly created cat profile and the admin group, those editors that we saw earlier. And here we create a relationship between our cat profile ID and our user ID, so the owner's relationship. So this way we have some data created on Eriketo. Okay, let's see now how we can make use of it. Yeah. If things go wrong, we roll back and delete those relationships. So to check permission, we need a case, and a good case is when we want to update an existing cat profile. So this is the endpoint. We would have two guards, so the ORI authentication guard that we saw earlier, and a new one, the ORI authorization guard. So this is also a part of that set of library that I mentioned, that here will instead interact with Eriketo permissions API. And in that decorator, in the ORI permission check, you declare for that given controller method what are the conditions to evaluate. So what my guard should send to Eriketo to evaluate. And here we will ask Eriketo, is this user an owner or is this user an admin? Now for the evaluation of the permission, we just saw some function earlier. So just to make a link, the is owner permission and is admin permission. Now we will dig into them. So the is admin permission will just take values from the request, so from the execution context, to be more accurate from NestJS, retrieve the user ID, and here also the request parameters passed in the path, and construct the relationship. So this is also some API that I created to make it handy to compose a relationship or a permission query. Here you can really verbally state this one. So the subject user with that given ID is in members of group admin. I think I do not imagine that. We can all read that and say it verbally. Same for this one. And that's literally what we send to Origeto to evaluate. All right. Since I'm a bit late on the schedule, I see that I'm at 40-something minutes, I will just show some recording of the interaction with the backend. Hope it's fine for you, instead of just doing it on live coding where things are going to take a bit more time. So what we will do is just to spin up the project, do the login, the registration, of course, before it, and interact with the API and see those authorization check in action. And eventually also see how to automate that with some end-to-end test, because I think that's a very interesting part. So we would configure our ORI containers. I think we'll skip that part, make it faster, with just a little bit of environment variables. Let's skip that. You can have access anyway to the code or that article if you want to know more how to configure it, or ask me. Yep. Let's make it run. Do you see it correctly? Yeah. So here we are on the self-service UI that I mentioned. So that's the pre-built front end from ORI Kratos. Of course, you can reuse and build your own UI component using the self-service API. Nothing forbids you, but if you are lazy or want to get started very fast, that's really, as I said, an ideal step. So here, okay, I will create that user, my email address, good ID to show that publicly. Then we need to verify the account. To do so, we will access that mail slurper UI that I mentioned. Right. Okay, now we are verified. Our backend should accept our login request. So we are going to log in via that UI. Let's try a failed attempt and see how that looks. Okay, we have the error here correctly rendered at the top of our form. Now let's try with a correct credential. Should work. Very good. Now, let's dissect a little bit what a session looks like in ORI. So you can see that you have all those properties, including the most interesting one, the session. But also some interesting parts is the authentication methods and authenticators assurance level. Hopefully you see it correctly. The resolution is maybe a bit blurry. Let me highlight it. So over there, you could have two values, AAL1 or AAL2. That allows you to check the level of authentication so that you can do, for instance, some step-up authentication. If you have sensitive operation, you could say that, okay, this session just have AL1. This given operation requires AL2, so requires signing in with a TOTP or with a security key. That's what you could check. Right, so that's our session. You also have account setting view where you can manage the TOTP and security keys and passkeys and so on and so forth. So everything is built in that self-service UI. All right, so we have a bunch, well, we have a single user. So ideally we want several users, including an admin and a nobody, just to be the witness and check out what authorization is working. So this is the CLI that we would use to make things, but we will skip that to make it faster. So we'll skip that. Now let's go test our API. So we have a user, an admin, and a nobody. Now we want to create a cat profile with our first user. So important. First, let's call it Alice to identify her later more easily. Okay, so Alice creates a cat profile. Okay, very good. We can see the owner ID. Let me take my pen again. We have our owner ID here. Okay, so that's IDs, Alice IDs. Now let's take that cat profile ID and use it for an update request. So now we take the session token from another user, which is the admin, and the admin should be able to edit. Very good, so the admin was able to edit. Now we take the session token from the third user, the nobody, who should not be able to edit. So we take that token, we pass it in our variable, and we'll send a request with that token. And here it is. The request is forbidden. So Ghetto did its job. Here we have a bit more complex example with the fostering requests, but for the sake of time, I will just skip it. You will have to trust me that it works, but the idea here is simple, is that when you create a fostering request, only the owner of the cat profile should edit, should be able to approve or reject the request, and only the participant should be able to edit. Now instead, let's have a look at how we can automate that, because I think it's more interesting. So we'll see how that with Jest, and use the Jest hooks to set up our test, and also tear down the setup so that everything runs as before when the test suite is done. So we have our setup hook. Here we trigger the function that will generate our configuration files with a specific environment file, as you can see here. Here we have a specific data.env.ci file, which contains some different value than those used in local development. So we do that for Kratos and Keto. Then we restart our container so that they consume those configuration files. And we initialize a clean database connection to isolate our entities for the test environment. All right, for the setup. Now for the teardown, we will close the connection, clean up everything. We will revert our changes, so regenerate the configuration as it was before, and restart our Docker containers. Now for the test, you will see that it's pretty simple. As soon as you have those factories ready, so a factory to create an admin user, a factory to create that admin relationship, and another factory to create another user that will be just a regular simple user. Here, let's make the assumption that we have our backend running for those tests, obviously. You could just run your check, run your request, as you would do locally, but with the comfort of the automation. So that's what we would do here. We would check our API cat profile creation. So we would check for the authentication over there. Should work. Update. The case where the user is owner should work. The case where the user is admin should also work, obviously. But the case where the user is a nobody, it should not work. And we can extend that logic to the fostering request very easily. I could show you a run of the test, but I guess you can just believe me that it works. Otherwise, you can just access the repo and run it by yourself. Now to conclude, so here we saw the story of Ori in a greenfield project. So a pretty complex journey, but still way less complex than when you have to convert an existing project to one using Ori. So of course, it comes with some challenges related to migration of your user and permission, and challenges on how to manage your environments. So when I mean environments, I mean local environment, test environment, CI, production, staging, so on and so forth. So as long for the user migration, as long as you have access to your user data, and even better, to the password hashes, ORI supports many hashes, from bcrypt. Well, I'm going to lie if I said I have the list right now, but I think they support 5 or 6 different algorithms that if you know where the salt and the value of the salt is placed, it can just take those hashes and put the password in their own database, and that's a zero effort migration for user. You don't have to log them out, they don't even know about it. Worst case, you need to reset your user password and, well, ask them to log in once more and create a new password. Then you would use the identity API for that purpose to just do some batch request and send all your existing user to Kratos. Really very pretty straightforward. It's a bit more complicated for authorization. Here, from my experience, I would suggest that you go step by step. So you identify one permission, you dedicate your effort into it, you ensure that it's correctly end-to-end tested and even eventually manually tested, and you map that existing permission to an Oriketo permission. You eventually adapt and run your end-to-end test once more, and deploy and repeat until you get it right for all your permission. Of course, if you have the time and the resources, you can go all at once, but I would not advise doing this. To manage multiple environments, I think what's one of the great strengths of ORI is that since it's totally open source, you can stick with it for your local development, for your test environment, and for your CI environment, because that's super easy to set up. I hope I convinced you. And I would really highly suggest to move to ORI Network for staging and production, because they have a very fair price. Even to get started, you can even get started for free. And you can replicate your configuration using the template very easily to your staging and production environment. Really, that's 1 hour to not even 1 day effort. Then it's up to you to decide if you want to benefit from all the certification at a given cost, or if you want to do the effort of the maintenance of some new services and add a burden of some operative work in your company. And then I would also suggest to use some vaults, such as .n for HashiCorp, so that you can share all your environment variables between all the stages. And then it makes the management of environment variables a breeze, at least from my experience. If you access the slide, you can have a link to those resources, so articles, the source code that is used and demonstrated in this presentation, links to the GitHub repository. And that's it for this long presentation. Thanks.